So today's lecture is going to be on methods. So you've probably learned about methods in other class, but one of the things I hope to teach you is not only just how to write methods in C#, but also the why you're writing methods and the proper way to write methods. So the whole point of writing a method in any programming language is to modularize your program. And one thing I want you to keep in mind is whenever you create a method, try to make that method as small as possible and only do one task. Now this isn't always possible, but it's kind of just a guideline that I like to follow when I'm creating my programs. Now your ability to create methods really can separate, a good programmer from a great programmer, or the difference between a programmer and a software engineer. And that's one of the things from this lecture forward that you're going to start hearing me talk more and more about, is not just the C# syntax of creating methods and classes and objects and connecting to databases, but why you're creating methods and classes and objects and things like that. So the first thing I want to talk about now is, while we go through all the C# syntax today, I'm also going to be trying to talk about why you're creating those methods that way. And again, in future lectures, we'll go over that more and more. So let's go ahead and let's just start. I have a little sample application that I created here, just a little Windows Forms. And let's start by just creating a method. So I'm going to use the private keyword because I don't want anyone outside this method to use this is an internal method. My class is the only one that's going to use it. I'm going to have it return an integer, and I'm going to call it square, and I'm going to have it pass in an integer parameter. So I've now created my int square. Now you'll notice that right off the bat it tells me, hey, something's wrong here. I have a compilation error, and it says not all code paths return a value. Well, that is a true statement because I've said that I'm going to have my method return an int. And you can see it's even tried to figure out the IntelliSense, and it's gotten better and better to the point now where they noticed that I called my method square, and they're actually trying to suggest I use the math.square root in this particular case. So they were close, but not perfect. But let's do our own little, again, math routine here, where I'm going to say y times y is the return value. So that's the square of y. So let's sort of dissect now our method. So again, when you're creating methods, you want to create it as small and as concise as possible so that if there's ever a bug and you're looking through your program and you're noticing, hey, whenever I'm multiplying a square of a number, it's off, right? So you can think to yourself, oh, well, I've got one method. Maybe you come in here, and again, maybe this was a complex formula, and you can say, oh, there it is. But if this was a part of the rest of your methods, and all you ever did was just copy and paste this, there could be 10, 20 places you would have to fix it everywhere rather than just one place. You're going to learn the hard way over the years where rather than copy and pasting, you didn't create a method. It's something you just, as a programmer, have to learn the hard way. Now, the next thing I suggest is every time you're writing a method, don't forget to comment. Don't do this at the end. Okay, don't write like 500 methods and then go back and comment them. Your comments will never be as good. And I promise you, take a breath. Every single time you get done writing a method, fully comment it. I know that seems like overkill and it seems like a waste of time and it can slow down your progress, but over the long run, you'll see the wisdom in that, and you'll go back and you'll be like, oh, and your comments will actually be helpful to you and others. I can't drill that in enough. So again, we'll say this is the square of the number, whatever, it doesn't matter. And then we can come down here to y, pass in the number, and then your returns, you would return the square root. So if I didn't want to return a value, I could have used the void keyword. But in our instance, we do actually want to do that. And I'm saying I want to take in an integer parameter called y, and you could have as many parameters as you want passed in of different types, and that makes up our method signature. So a very basic program. If we had wanted to use this outside of our class, so we're essentially saying this method is going to be helpful for someone outside of our class to use rather than just internally, we would make that public. So if someone instantiates our class, they can say dot square, and that would give them that ability. So let's just go ahead and make it private. And again, just every time you create a method, just think through what you're doing, comment it, and make it small and concise, and then fully test that method before you move on. You'll save yourself so many headaches with bugs. So let's go ahead now and let's go to some programs in the book. So I'm going to go to figure 7.3. And this one here is called the maximum finder class. So again, this goes back to that architecting of why you're creating this class, because maybe at your work you're breaking out different quantities of work between each individual. Your job is this very complex scenario where you need to find the maximum of these values. Now again, obviously that's a simple task, but let's just imagine it's very, very difficult. So someone hands you that task and you have to now figure it out. So one way to do that is to encapsulate it in a class called Maximum Finder so that someone else could use this class. Now again, we're using it with a console. I'm just using this as an example that you could create your own class to get some data and find the maximum of it. So we got this console program. We've already learned this. We're printing it out. Hey, enter a floating point value. And here's how we read it in. Now, we need to be very, very careful whenever we're getting user input from the console or the GUI, wherever else. Now, hopefully you can see by now that this is a problem. Because if I were to enter in the letter A and I tried to parse it into a double, this is going to throw an exception and crash my program. So we always want to use the .try_parse, whether that's int32.try_parse or double.try_parse. Now next, I wanted to show you the convert class. So the convert class is just another way that you can force the code to convert the data from one type to another that you need. And you can see there's lots of different things that you can convert to or from. The other thing you want to be careful of is just understanding that the idea of widening or narrowing conversions. So if I'm going from, let's say, an int to a double or an int to a string, that's widening because the one data type is smaller than the other. So I'm not going to lose any data going from an int into a string. Now narrowing, that's generally where you're explicitly going to have to tell C#, hey, I know what I'm doing. I know I'm going from a double into an integer because there's potential to lose data there, right? 26.6, if you convert that to an integer, you're going to lose some data. But if that's the correct thing to do, then that's why you have to explicitly cast these things into your program. So let's go through this a little bit more. So we just get some numbers from the console, okay. And now our goal is to find the maximum of those numbers. So what they've done is they've said, okay, this is the perfect opportunity to create a method called maximum. So we can see down here our maximum method. For right now, let's not worry too much about the static keyword. We're going to learn more and more of that as time goes on. We get more into classes and objects. But for now, let's just look at this method called maximum. Returns a double, which is the maximum value of the three values that are going to get passed in. Then they just run a quick algorithm down here just to figure out, hey, which one is the maximum value? Is this value greater than this one? And then they return whatever the maximum value was of these three. I also want to point out the comments here. And again, this was just XML comments, so if I were to actually get rid of these and type 3 forward slashes, you can see it actually puts in the XML comments for me. The summary, and then a comment for each of the three parameters, and the return type. Now, why do I continually talk about comments? Well, again, imagine someone was using this maximum method outside of your class, they would need to know how to use it. And so if I highlight maximum, you can see that right here returns the maximum of its three double parameters, which is the value here. So someone then can see this and say, oh, I know what this method does. Oh, I also know what this return value is. The same way that within each parameter, you can see that right here, it's going to tell you, hey, what value are you expecting in? Now, of course, this method is really easy to understand, but a lot of methods are not. So you're just giving some hints as to what this method is expecting to pass in. So that's kind of the gist of what this whole program does. But again, in the future, if you're testing this program and you enter the three numbers and it doesn't give you the result that you want, you probably don't have to worry about your main method. You just have to look in the maximum method. Now again, just think of that. That's an easy concept here, but just imagine you had 50 different methods of getting user input and maximum and minimum and averages and all these math algorithms. But you just notice the only part of your program that isn't working correctly is occasionally the maximum isn't returning the correct number. So you just go into this one area. You can drill right into this. Or someone maintaining your code 10 years from now knows where to look. And they can get in here real fast and just figure out where the actual bug is. Yes, you will write code that has bugs in it. We all do. It's just impossible not to. So now I'm going to go back to this Windows program that I started with, and let's kind of talk about some of the GUI aspects of our program. So with that, in our form 1, there was this Initialize component method. And so if I were to right click on this and click Go to Definition, you'll see that it takes me to that partial class. That's this designer file right here. So we've got our C# and our designer file, which actually get compiled down into the exact same file. Now this initialize component is just a method that they created for us that essentially is written for us just to create all of the GUI components for our user interface. So when we drag and drop, it's just writing the code in here for us. That's all it is. Now there's another method in here called Dispose. We'll learn more about Dispose and garbage collection as we start getting into more in classes and objects, but for here I just wanted to point it out that this override, what it's saying is that since everything inherits from object, we're getting this dispose method for free, but maybe there's times where you need to dispose of objects specifically. And in this case, it's disposing this container, which is called components. But we could also put any code in here we wanted to that we wanted to guarantee some resource got cleaned up that the garbage collector may not know about. So again, I just wanted to show you another use of methods in C#. We've also kind of learned about GUI program. And let me come up here and let's open up our toolbox. Oop, maybe not. Let's go back, open up our toolbox, and I'm just going to drag a quick button over here. Now when I double click this button, it creates this event handler. This is just a method. That's all this part is, different from no other method. The only reason this method gets called when our button gets clicked is because over here in our code, it actually wired up our events for us. So if we were to come up here, or actually, sorry, down here, highlight our button 1, we can see everywhere that our button 1 is being initialized. Here's where it actually creates the instance of that button. Here's all the properties that got set for us. And then down here is where it actually linked up this event called click, and we're telling it, hey, when the event called click, so users click the button, I want you to call this method. So it's a way of passing a method into this object, and we'll learn more about that later, but I just wanted to show you how that sort of black magic works behind the scenes for this method. Again, this is just a regular method, and the only reason it happens when you click a button is because of this statement over here. So now let's just kind of reiterate namespaces and the using statement and things like that. So if we come back over here to this figure 7.6, this program talks about random integers. And we've learned about the random class a little bit, but let's go through that again. So this is a class. So remember, this is that blueprint. So we actually have to instantiate an object of the random class. That's why we have this new keyword. This right here is just an object reference to the actual instantiated object. Down here, we're going to use the random class to pick a number between 1 and 6. So this number is inclusive, this number is exclusive. So it's between 1 and 6. I don't know why. They could have programmed this to be 6, but they just chose to make the method this way. Don't ask me why. But notice how I can just say Random.Next, right? So if I come over here to random, you'll see that it's actually part of the system namespace. Well, here's the system namespace. And so in my references here, sure enough, here is the system DLL. So this is code that Microsoft wrote for us that we're essentially getting for free. Now, if I were to delete this right here, it wouldn't matter if I had the using statement or this code. It would have no idea what the random class is. The only reason it does is because I've included this DLL in my code. And I didn't want to have to write system.random each time, so I put the using statement at the top so that I can just reference the random class. So that this random is part of the framework class library that's located in this the system.dll. Just important to remember. So now let's take a look at another random class. Now this one does something very similar where we've just instantiated the random class, and it's just going to keep track of the frequency of each of the rolled dice, essentially. So what we're going to do is we're going to loop through 60 million times. I'm going to say that again, 60 million times. Each time through this for loop, we're going to select a number between 1 and 6, and all we're going to do is increase each variable by 1 up here based on which roll gets set. Now this can show us just how random this random number generator is. Now this random number generator class is just perfect for something like this, for a simple little game. This would not be good for encryption, or if you were really writing an application for gambling or things like that. There are other classes that are a lot better at generating actual random numbers. Now, the reason I like this one is because I just like to run a program that runs 60 million times. So let's go ahead and do this. I start it up. Now, of course, this is going to change based on your program, but look at that. Within a couple seconds, that program iterated 60 million times, and you can see, while not perfect, we never expect it to be perfect, but we can see that there's a good, nice random distribution between 1 and 6. If this only had 5,000 and then all the rest were even, we could see that that was not a very random generator, where this one is. But I just find it fascinating to get that perception a little bit of how fast a computer is actually running. And I just love that about computer science. It's just so hard to grasp what the computer is actually doing when you're playing a game or a simple program like this, of just the computing power of mathematics in a computer. It's so good at it. So let's go ahead and move on to the next example here. This is figure 7.8, and this is a craps program. Now, the thing I like about this program is it uses something called enumerations. Now, I found that enumerations are a little bit of a concept for students to grasp the first time. So the only thing I can say is try to really pay attention in this next piece of the lecture here, but then go out and try to write these pieces yourself, and that'll really help that part of the lecture sink in. So what is exactly an enumeration? So enumeration is just a way for you to define values of your application. Now, I see a lot of places where people define specific strings, but the reason you don't want to do that is because a string value can hold any value, where an enumeration can only hold the specific values that you dictate it that it can hold. So in this particular one, we're going to create a craps game. Now, you don't have to understand the rules of craps, but I can just explain the basics of it to you. So the first enumeration that we're coming up here is something called status. Now, this enumeration is defining 3 values. One's continue, one is won, as one is lost. Another enumeration has to do with the possible rolls of 2 dice and the rules of craps. So for instance, in craps, if you roll 2 dice and you get a 2, it's called snake eyes. Again, you roll 7, it's a 7, etc. 12 is boxcars. Again, we don't need to worry about that, but we're just saying that when you roll the dice, these specific dice rolls have specific names and meaning to our program. But it's impossible to roll, for instance, 1 with 2 dice. So it's not something we need to define. And the other values, like a 5 or a 4, also don't matter for our particular, you have to roll again. So it doesn't matter for these specific common rolls of the dice. So let's now show how we're going to actually use this enumeration to show us in our program to make it more readable, and how we can pass in certain values to methods so that we can control what gets passed into our methods. So as our game is being played, you can see that right here is a variable of type game status. So let's create our own variable of type game status. So if I come up here and I type status, we're going to create a variable just like we do an int or a string or anything like that. And so I'm just going to call this my status. Now this is just a variable. Now I expect this variable, so like a string, let's also create a string called sMyStatus. Now sMyStatus can literally hold any value I want, right? It's a string. It can put anything I want in here. Now, I could just as easily say continue or won or lost, and that works fine. But again, imagine someone's passing this in as a method, and they're going to pass in continue, won, or lost. Well, if they do that, they could pass in, won or lost or continue or continue. It doesn't matter. There's so many different ways that they're going to pass in this value or define what this status is, rather than the values that I'm expecting or want them to pass in. So what I mean by that is, let's actually go back to our variable now and say equal, and you can see it even comes up, hey, I know you're talking about the status type. So if I press dot, you can see that it says, hey, there's only 3 possible values you can store into this enumeration, like lost, for instance. And so now what I could do is in my if statement, I could say, if you can see it pops up here for me, we can now write a statement like this that is a lot more readable than if I had a string, something like this, that says lost. Now again, this works, and I see this all the time, but it can have bugs, it's a little more error prone, and it's not as readable. And we'll show methods, the advantages of methods in just a second. So right here, when you're reading my code, I'm saying, okay, if the status is lost, essentially. But notice, again, it can only be the predefined values. So now let's go back to the program here. And you can see here's my game status, and my game status is initialized to continue. Because again, you can continue, you can win it, or you can lose, essentially. Now we're going to come in here and we're going to roll the dice. So I can right click, go to definition, and here's my method. So again, my method only does one thing. What does it do? It rolls 2 dice. It takes 2 random numbers, adds them together for the sum, writes it out, and then returns the sum. That's all this method does. So now as we come back up here, we can see we get these 2 numbers. So let's pretend we did, 1 and 3 or 4 and 3, whatever. And you'll notice that we take this integer and we're actually going to cast it to type DiceName because enumerations are by default actually integers. So this is 0, this is 1, and this is 2. Now watch what happens when I highlight this. You can actually see that it's showing me that it's actually telling me, hey, there actually is an integer value assigned to 1 or lost. Or you can actually hard code what each of those values are, because they're just integer types within here. So that's why here I can say, hey, take this number, cast it to a DiceName enumeration so that my switch statements can now use my enumeration. So again, if you know craps, this is a lot more readable than if you just had plugged in the numbers up through here. So I can now use the lingo of the game in order to set my game status. So 7 or 11 means you've won the game. These values mean you've lost the game. Otherwise, you can continue the game and start rolling again. And that's where this code starts with this down here until you win a particular value and then you've won the game. Again, we don't need to go through that sort of stuff. We really just want you to understand the idea of what an enumeration does for us. So let's just kind of do that again now. I'm going to create, it doesn't really matter if it's public or private. So just like we did up here, we have these enumerations, right? Private enum status continue, won and lost. So let's come down here and let's say private enum. And I actually just press tab. It's kind of nice. It just figures it out for you. Instead of this, let's call this days of week. And we're going to define what it means. So we have Monday, Tuesday, and Wednesday. Obviously, there's more, but that's what we're going to do for our code. And now we're going to create a method called, it's my method. It doesn't matter what this method does, but this method, I'm going to do something based on the user passing in to me what day of the week it is. And so I could have had a string as day of week. So this is perfectly valid. Okay, but now I'm going to do an if statement based on if it's Monday, I need to write a method called go to work. If it's Saturday, I do something say that goes to the movies. Whatever I'm trying to write in my code here. Well, if I say day of week equals, okay, so now I want to do something if it's Monday, right? Okay, cool. So let's say Monday. All right, but let's say someone else is using this method outside my class and they say, oh, day of week, I'm going to pass in Monday. And they pass it in this way. Well, right, this isn't going to match up days of week here. Well, what if they pass in mon for days of week, right? There's a million different iterations of how you could pass in that variable. So in order for you to qualify exactly what the person is going to pass in, let's do this. And so a lot of times I'll do something like E for enumeration days of week. Now you'll notice that this is specific to days of week and there's only specific values that the user can pass in. So now I can do something like this and say, hey, my days of week, which I changed, is equal to this, therefore I can do something with that value. So how is this actually used? Well, let's come up here now and let's write my method. And again, let's pretend that someone Outside, actually, no, we'll just create ourselves another little method here. Doesn't matter. And so now our little method here, we're going to try to call my method. So I start typing my method. Now when I open this up, you can see it already tells me, hey, I'm expecting in a days of the week dot, oh, it's giving me the only possible values I can pass in now. It tells me Monday, Tuesday, Wednesday, right? So this is straightforward how to use this method now. I can't pass in a string. I can't pass in mon or all caps or lowercase. I have to pass in a very specific value. So that's how that days of week works there with that enumeration. So next thing I want to talk about is scope. So this is figure 7.9. So what we want to talk about now is class scope versus method scope. Now just real quickly, this static keyword, it's not necessary for what we're trying to do here in our application, but what it really means is when this program starts, there's only going to be in our application one variable called x, and that is it. That's what static means. It means there's just one instance in our entire program. And so again, we'll learn more about that later, but I just wanted to point that out. Now, something that happens here is this variable is going to be around as long as this class is around, where this local method, this local variable to this method main is only going to exist from here to when this method exit, and garbage collection will take care of that for us. So that's the class level scope versus the method level scope. Now within this application, you'll notice that we have this variable x here at the class level, and notice when I highlight this that it does not highlight this variable x here. And if I scroll down, you can see that it actually does highlight these other x's that are actually referring to this class level variable x. Now this variable x is local to this method. Now I would recommend that you don't do this. Now there may be times where it makes sense to do this, but generally speaking, I almost never use a class level variable name that's the exact same as a method level name, because again, you could have 100 methods, and imagine you're looking at your code like this and you forget that above you have this variable x, and it can just wreak havoc on bugs and things like that, or maintainability. Again, there are reasons why you may want to sometimes, but for the most part don't. So this local scope means that if I say x equals 4, I'm assigning x to this variable, not this variable. If I want to reference this variable up here, I have to use what's called the this keyword. And so when I say this dot x, it's going to now refer to this x up here. Now, because we're using static, the this keyword doesn't exist. We'll learn about that later on. I was just kind of using that as a concept for what we're doing right there. So that's sort of local variables versus class variables. Now let's just kind of walk through this program a little bit as it starts out. And so here's this local variable x that we're just going to print out. Now we're going to call this method called useLocalVariable. So again, we're creating a local variable x that we're going to print out here. And notice that we're incrementing x, but this x that we're incrementing only exists from here to here. We're not incrementing the class level variable x. Now this static variable, if we come down to this method, and again I highlight this variable is actually our class level variable up here called x. So it is actually modifying the class level variable. And then again you see local variable, and then they're calling the same method again just to show you that it doesn't, this never interacts with this variable up here. And same thing here where it used static variables. So it's just showing you the difference between local and a class level variable. The next thing we want to talk about is methods and how you overload them. So this is figure 7.14, and we're going to talk about a method called square that they've created for us. Now you'll notice that this square method is actually created twice in this particular program. One time it's going to return an integer, one time it's going to return a double. Now the reason for that is sometimes you pass in an int or sometimes you pass in a double. Now up here you'll see that there's no difference on how you call this method. So what you may be in charge of is creating a whole separate chunk of code that has all these math algorithms, and maybe one of them is called square. Well, someone doesn't care about squaring methods. You're going to take care of that complexity. They just want to use your method. And so to use it, they just want to call square. And you know what? They want to pass in any type, whether it's an integer or a double or single, whatever it is, it doesn't matter. And that's why you use method overloading. So that as far as the user is concerned, they're just calling the square method. But there may be times where you need to write different code. In this case, it's exactly the same, but there may be times where you want it to do something different based on the types that are passed in here. And so this is called method overloading. Now, the key thing to understand here is this return type is not part of the method signature that it knows on which method to call. So what I mean by that is the method name, the type of the parameter, or the number of parameters is how the compiler can know to call this one versus this one. But the compiler does not use the return type to figure it out. So up here, you'll notice that if I highlight square, it knows to call this square method, not this one, because it notices that an integer is being passed in. Now I also could have had, something called like this. Now up here, I would have to then, if I do this, it knows to call this method and not this one because the number of parameters that I'm using. So that's how that works. So that's called method overloading. So it's just a very helpful way to make this piece of code cleaner, where you're going to want just different types or different number of arguments passed in from the user. So related to this, we're going to take a look at figure 715, and this is optional parameters. So you'll notice here that while yes, we're using method overloading in a sense, we actually only wrote one method. However, we can actually call this two different ways. So you'll notice this calls power and this calls power. But there's only one method that it's calling. But over here, you'll notice that this one actually passes in this optional parameter where this one doesn't. So what is an optional parameter? It's where you assign a value, and it basically says, hey, if they didn't pass in a value for this one, it's optional. We're just going to go ahead and set it to 2. So what that looks like is if I come down here to power and I type in this, notice this syntax right here with the blocks. That's telling you that, hey, if you don't pass in a value, you're going to get the value 2. So if you don't want 2, you pass that in. And this happens all the time where it's like, oh, I don't need to worry about that. I'm expecting it to, I want the square of it. So therefore, I'm not even going to pass in a value to this method. So that's how that works with this optional parameters. So the next we want to talk about here is recursion. So with recursion, we're going to have a method that calls itself. Now, the vast majority of the time that I've had to use recursion had to do with something like searching a file system, like your Windows file system, going through File Explorer. That's one of the cases where I've used this factorial and recursions type idea over and over again. So what it does is you'll notice that within this factorial method, it actually calls itself. So it can call itself and call itself and call itself, but then it has to back out of that chain. Sort of like your file system. So if you can start at your desktop, you go to a folder on your desktop, which may have 3 other folders, but you go down one of those, and then you can go back up. Well, that's what it's doing here, where there's some condition where if the number is less than 1, that's where it returns out of this method. But otherwise, it's just going to continually call this method over and over again. Next concept I want to talk about is ref and out keywords. Now, this next part can be a little bit confusing, but it's a concept that you really important and we want to grasp. So let's talk about value types and reference types. So these variables here are of type int. An integer is what's called a value type. Now, a value type means that when I actually declare this right here, int y, behind the scenes, .NET is actually creating a peg hole in memory that is 32 bits wide and actually contains the number 5. So that little area in memory actually contains the number 5. Where a reference type, so for example, we just learned about the random class. If I were to do just this, like we've learned before, this is an object reference. So this creates a peg hole in memory that holds nothing at the moment, right? This is just the blueprint. We haven't actually created the house. But as soon as we say new random number, this actually instantiates the object. Now this returns what's essentially is a memory address, a pointer. Even though in C# we don't use them, behind the scenes that's what's going on. So this object reference actually holds just a reference to where the actual object exists in memory. So there are two different places. This little peg hole in memory holds the object reference, the address essentially, to somewhere else in memory where this huge, large, random object actually is created. So this could take up a tremendous amount of memory, versus this little peg hole is just holds an address and that's all. So this is an object reference, which holds an reference to an object, where a value type, something like an integer, this variable holds the actual value. See, this doesn't hold the actual value. This holds an address to point to the actual value. So let's come back now to these value types and the different ways that we can use value types. So what we can do now is we can call methods different ways based on how we want these methods to manipulate the data. So let's take a look at these two different methods, square ref and square out. And you'll notice these ref and out keywords. But let's take a look at the methods themselves and figure out what they're even trying to do. So if we come down here to square ref, you'll notice that we have this ref keyword and then an int x parameter passed in. Now, for just one second, let's delete this, right? This is a method that we've seen all the time. But when you look at this method, it really doesn't do anything, because we have x is basically exists from here when it's declared to here. It doesn't return any values, it doesn't set any values, and so it doesn't do anything. But if we just put this ref keyword in here, it does actually do something. Now the reference keyword, what it does is it says, I expect you to pass in a value of x, but oh, by the way, I'm also going to return a value back out of x. So what this does is, this is a value type, but I'm saying I want to pass it by reference. So let me say that again. So even though x is a value type, you're explicitly telling it that you want to pass it by reference. Well, why would you want to do that? Well, normally, if you were just to do this, the value you pass into x up above here, it passes in a copy. And so let's say the int x up above has 5. When you pass in 5 to here and do whatever with 5, it only manipulates the value 5 here. It's a copy, right? So up above, the value is still 5. But if I pass in with this reference keyword, I'm actually now pointing back to the original int x up here. So you'll notice that this y variable of 5, I'm actually passing in now a reference back to this original y, not a copy of it. So what that means is that the 5 that I pass in here is not a copy, but it's the actual memory location. So 5 times 5 equals 25. And now I've just overwritten 5 with 25, so that when I come back out of this method here, this value y now contains the value 25. So the ref keyword allows us to pass a value back out. So what's the difference between the ref keyword and the out keyword? Well, if we come down here to the out keyword, it's going to look a lot the same as this reference. So you'll notice here's the out keyword, which also has to be used up here, just like the ref keyword also has to be used. So for example, if I did this, you're going to get a compile error. So you have to explicitly say I'm passing this by reference. This value type, I'm passing it by reference. Now for the out keyword, what it essentially says is I'm only going to pass out the value x. It means I don't care what you pass in. Now you're still passing this by reference, but I don't care. I'm not going to use the value that you pass in. Now notice what happens here is I'm actually assigning it a value, then doing the multiplication, and it assigns x. So x gets returned through this variable here. Now if we were to come back up here, notice the difference between int y and int z. Now remember, reference parameters, we expect expect this value to also be a value to be passed in. That's why up here you have to actually initialize this value. So if there's the ref keyword, it expects a value in, so y must be used or used up here, else that's going to create a compile error for you, because you're essentially, it's expecting to use this value y as you pass it in. Now down here, this is again a regular method where when we call square of the y and the z, it's going to pass in a copy of these values. It's not passing by reference. And that may take a little bit to sink in, but it's just something you have to use a few times writing your own program, and then it'll make more and more sense. So now let's do this same idea here, but let's use what's called a reference type. So for instance, we have like our random object, right? So let's create my method again. Oh, forgot the void keyword. And now in my method, we're going to call another method, public void my method 2. But now in my method 2, we actually want to pass in a variable of the random class in order to be used in our method. Now, you'll notice that I'm not using the ref or out keywords here at all. Now what I'm going to do in this method up here, I'm going to use random, let's say my random equals new random class. So here's where I've actually instantiated the object. Now again, imagine I'm writing this method here and I say, Rnd.Next, and I pass in, between 0 and 7. So I'm trying to figure out a value between, I guess let's say 1 and 6 is essentially what I'm trying to do here. Now what can happen right here? Well, our program could crash, because again, remember, maybe this method was in a separate class. Well, if someone doesn't actually pass in this, watch what can happen. This is perfectly legitimate to say null right here. You could do this, and it's going to be just fine. So your program's going to crash. So one way you could do this is to say if RND does not equal null, for example. That would be a way that you could guarantee, right, that an object has actually been passed into your class. Now, with that said, what you'll notice is that what we actually want it to do is we're going to pass in this random object to our method. Now this, by default, is passed by reference. So up here, because these were value types, they got passed by value. There's an actual copy created in memory. But down here, because this is an object, it's automatically passed by reference. So let's think about why C# is set up that way. Well, instead, let's create, maybe just to drill this home, clsEmployee. Now this particular class, you could have 1,000 attributes and 1,000 methods inside this class employee, right? You could have first name, last name, social security number, height, weight, and then methods that insert into the database or do whatever you want. Well, this could take up a tremendous amount of memory. So if you're passing that into a method here, so let's change it to clsEmployee. You wouldn't want to make a copy of this every time you passed it into your method, because that could just create a ton of extra memory. So instead you pass a reference. So that's why this is automatically passed by reference. So that when you actually use this object in your code and you say dot, you're actually manipulating the original object, not a copy of that object. So now let's just kind of go full circle now, and here's a example program that I've created for you called Chapter 7 Methods Random Guess. And it's a really simple program. And what it does is when you click the play button, it generates 2 random numbers. You can enter in a guess, click submit, and it's going to tell you if you're right or wrong. Click play again, we can type another guess in here and it says you are right. That's all there is to this program. But we want to say, okay, here's our problem. Now think about the methods behind this program. So while I haven't done this, there's lots of different methods you could create. So for instance, you could have a method that just validates the user guess. So essentially, it says validate, something like that, so that you know later on that if they click submit with like the letter A and this crashes your program, you know exactly where that goes. Also, we're going to create a method that actually takes these two numbers, adds them up, and says, hey, is that equal to this number? And we're actually going to then not only calculate that, we're going to return a true or false as to whether that actually occurred. So first we're going to need two private class level variables, and that'll make sense why they're class level in just a second, called first number and second number, and that's the values that we're going to randomly generate. Now when the user clicks play, we're going to create the random class. Now this could have been also created as a class level variable rather than recreating it each time, but for our simple program it doesn't really matter. And then each time we run this, we're going to create a random number between 1 and 10, again between inclusive and exclusive here, the way they chose to do it. Then, we're going to create this display numbers. And all it does is it takes these two numbers and it displays them to the user. Now again, this is a very simple method, but later on, if when we ran our program up here and we said play, and let's say it printed 3 and 3, then we click play and it printed 6 and 6, we click play and it printed 7 and 7. Oh, there's a bug in our program. We know exactly where we need to look. So we can come down here to display numbers and say, maybe what we did is a copy and paste, which I do all the time, where I said first number and first number instead of first and second number. But I know exactly where to go because my method does one single thing, and it just displays the data here. So now next, we're going to clear the screen. Now what I wanted to show you here, again, this is a very common mistake a lot of people do, where they'll just, rather than creating a clear method, they'll just copy and paste this code about 800 times. So maybe that makes sense here, maybe it makes sense here, maybe it makes sense down here. And then, oh, by the way, as soon as you have to have one more label, and now you have to update it, 5 or 6 times throughout your program. And I see this all the time in code. I do it myself because I didn't think ahead or plan ahead for even just something this simple. I promise you it'll bite you over and over again. And this is where that experience comes in. So next, when the user clicks submit, we want to try to figure out, okay, did the user enter the correct guess, yes or no? So the first thing we want to do is I'm going to use the try parse because I don't want to do anything if they enter in like a letter, for instance, or no number at all. And this will automatically convert whatever value they pass in. Then I'm going to call this method called calculateResult. Now notice from one single method, it returns the result, which is the two numbers added together, and it also returns whether the numbers matched or not. So you can see here's the out keyword. So this is really handy where you can have a method that actually returns two pieces of information, the result and whether or not the numbers matched. It just made sense to do both things within this method. So let's take a look at calculateResult. Now notice, because this deals with the out keyword, numbers matched, I don't care what gets passed in here. So down here, you'll notice here's is match. First off, we take our two class level variables, add them together for iCalculateResult, and that's the value we're going to return. But oh, by the way, we're going to take in the value that the user guessed and determine whether or not it matched the correct answer, and we're going to return that as a variable back out. That's why we have the out keyword, because we don't care what you pass in, we just wanted to pass back out the value whether the numbers matched or not. So this one method actually does two things for me. So the first thing I can do is I can display the result, and then I can use this Boolean variable in order to determine if that value was true or false. So we've learned a lot of concepts today, but hopefully things start to mesh a little bit, and the only thing I can say is to go back and start writing your own methods, test out the different concepts like enumerations or the ref or out keyword, and then as you create programs in our class, take a pause and think about which methods your program is going to create. Thank you.